Good afternoon, ladies and gentlemen. My name is Jeff Peters. I am the Southeast Regional Director here at WoodWorks. Thank you for having me today. Today, we're going to spend some time talking about building sustainably and wood's role in healthy forestry and healthy buildings. Before I get started today, I do want to give a special thank you to our funding partners who allow the WoodWorks organization to continue to provide these educational opportunities to the design community, as well as the technical support and project assistance that we provide all across the design community and extending out to general contractors and developers as well. And so just a quick thank you to the Softwood Lumber Board, the U.S. Department of Agriculture, and Forestry Innovation Investments. They are our primary funding partners for 2021. In addition to our primary funding partners, we also have board partners and market development partners. Without their support, their continued support of the WoodWorks organization, we simply would not be able to bring this type of education and the technical support and project assistance that we provide to the design community. I'd love to take this opportunity really to just tell you about the WoodWorks manufacturer and supply directory that we have on the woodworks.org website. This would give you an opportunity to jump on the website, look for different manufacturers and suppliers, see what goods and services they supply. Just a really powerful tool for you to spend some time looking around. Also, you can always reach out to me at any time as well if you have questions about what products may be available for a particular project. And speaking of projects, we do provide project support. So if you are designing any type of a commercial or multifamily wood building, we're here to provide that project support. We realize that perhaps maybe traditionally you've used maybe steel or concrete or other more carbon intensive materials to design your buildings. And now you're looking at potentially crossing over and learning a little bit more about how wood may be utilized in some of these commercial buildings that you're working on. And so we would love to be that expert for you to help walk you through the codes and the design requirements for commercial wood buildings as well as multifamily. And so just keep in mind that this does cover everything from light frame, heavy timber, mass timber, and even hybrid systems. We're available to provide support. Here is our AIA slide, just to let you know that we are an approved AIA provider. You can see our number is G516 right here on this slide. And then just a little bit about the learning objectives today. We're going to highlight North America's ecological capacity to support a diverse range of forests. We're going to discuss how using a variety of forest products can economically support healthy and sustainable forests. Next, we'll describe how wood's use can be leveraged in a number of green building rating systems that can help you achieve the certification that you need. And then we'll demonstrate how wood can contribute to sustainable development trends such as biophilic design and healthy buildings. So really a nice agenda for the day today. So let's jump right in. So overall, timber is an especially attractive option for sustainable buildings. You know, when compared to other woods, timber is much more energy efficient. It uses less water and it has a lower carbon footprint. So wood really is the backbone of our environment, and it consistently serves our needs and is always ready to do more when we call on it. So we know that we want to build sustainably, and we know that we want to build in these energy efficient techniques, while really not using up all of our natural resources. This is really starting to get to the core of what sustainability means. And so sustainability means being able to do something for the long term without really having adverse effects. I've been with WoodWorks now for almost 7 years, and one of the questions I hear on a regular basis is really like, what about our forests? You know, aren't we just cutting down everything, or how can this be a sustainable way of building when all this deforestation is happening? You know, I hear this all the time, and so you know, I would just want to take a few minutes to just kind of address those questions as well as I'm sure some of the other questions that we receive on a regular basis. So first, you know, is North America really running out of are we running out of our forests? Does specifying wood products contribute to deforestation, or is wood really, a renewable resource? Those are some of the common ones that we get. So This chart shows, in terms of acres of forest land in the US from our earliest estimates. Now we're talking way back before major development by European colonists to date. So keep in mind, conservative population estimates for the 1600s were roughly about 50 million in the US. By the 1960s, our population was approaching about 181 million. And as of October of 2013, we were close to 317 million people. So as you can see by this graph, even though our population has grown exponentially, the acres of available forest land has been very stable, and we've been able to keep up with the demand for timber over these years. This chart shows the volume of trees on timberland for a period of roughly 60 years or so. So as you can see, the volume of trees we have readily available for harvest has actually increased by 58% during this time period. Just to give you a baseline, there are three major regions shown in this graph. So we have the western region, which is indicated by the light green color. We have the south region indicated by the yellow color, and finally the northern region indicated by the brown color. The big item to note here is that, this does not include trees in national parks or wilderness areas, which are preserves. You know, they're not considered for potential harvesting activities. So remember to keep that in mind. So national forests or national parks and wilderness areas are not included in this data set. So keep that in mind. This is a fantastic map. This is a representation of what land is publicly owned, or should I say, really federal or state owned land, and what land is privately owned. So the dark green areas are publicly owned forest land, while the bright green is privately owned forest land. So as you can see, especially here in the South, we have an abundant amount of privately owned forest land with landowners who really are eager to find a market for the timber that they have on their land. So taking a closer look at the previous slide, private land ownership accounts for about 56% of our total forest land. Out of that 56%, there are more than 10 million individuals and family forest landowners that make up 42% of the total privately owned forest land. The other 14% of privately owned forest land is owned by corporations or partnerships and tribes. So what motivates these private landowners to keep forests on their land, right? What is really motivating them to do that? It's really very simple and clear. The economic value of forest products is certainly a major factor to many of these private landowners. The more economic incentive that we can create for sustainable forestry, the better. There is this saying in the world of timber: a forest that pays is a forest that stays. And I understand, that may be an oversimplification of what is really happening, but it really does illustrate the simple truth. And that, a forest's survival really depends in most cases on its value to the local community and the landowner. I want to take this opportunity to clear up kind of a very common misunderstanding about forestry. There is a tremendous misconception that when a landowner, they decide to cut several acres of forest land to harvest the trees that they've been growing, they've been managing those trees for the last 12 or 15 years, people start to believe that that's considered deforestation, right? Because you're cutting down all the trees. And that really couldn't be further from the truth. So to better really understand it, let's first define it. So deforestation is really the permanent removal of forests where the land is converted to other uses. So the key term there is it's permanent, right? That's when we have deforestation, when the land has been repurposed for something else and there's no intent ever of regrowing any type of timber on that land. So as you can see here in the background of this photo, you'll see that there was a clear cut and it's now a regenerating forest. Likewise, the growth in the foreground likely represents 10 or so years of growth following the harvest. So really a really powerful picture there that you can see the different stages. So moving on to the forest management side of this discussion, right? So what exactly does sustainable forestry mean? It's simply just a fancy term for good forestry. A good definition for sustainable forestry would be the art and science of creating, using, and conserving forests. The forestry profession was a pioneer in developing techniques for sustainable management, and then later on, techniques for multiple uses for that forest. So, in this photo below, you'll see a lot of landscape diversity in a Western Douglas fir working forest. You can just see different sizes of trees, just a major diversity in this forest. So in North America, our forests are actively monitored and managed in a very, very controlled environment. So the United Nations Food and Agriculture Organization defines sustainable forest management as the stewardship and use of forests and forest lands in a way and at a rate that maintains their biological diversity, their productivity, regeneration capacity, their vitality, and their potential to fulfill now and in the future, relevant ecological, economical, and social functions at local, national, and even global levels. And that does not cause damage on other ecosystems. So that's a pretty big mouthful, but nonetheless, just wanted to share that with you. Our national forest resources, they're managed to be sustainable. So they are here for the future. I'd like to point out that even though our national forests are required to develop and follow a sustainable forest plan, national forests are not, they are not enrolled in any type of a third party sustainable forestry management system. So for non-federal forest land, so state and local regulations apply to forestry management. That being said, there are sustainable forestry management systems available for private forest owners. So there are several similar sustainable forest certification systems that exist for private forest management. So let's talk a little bit about those. We have FSC, or the Forest Stewardship Council. We have SFI, or Sustainable Forestry Initiative. We have CSA, the Canadian Standards Association Sustainable Forest Management System, and ATFS, American Tree Farm System. Those are some of the common ones. So here are just a few of the similarities within the sustainable forestry management system. Just to highlight a few, we can maintain wildlife habitats, protection from deforestation, and audits of forest planning and practices. Just a few of them. So we're going to start with a journey basically from the forest to the city. So in this image, this is an image of a forest. This is one that was taken during one of the WoodWorks' tours of a logging site in Springfield, Oregon. The Douglas fir trees here are harvested at a 45 to 50-year rotation, and regulations require new trees be replanted within the first few years of harvesting. So we talked with a lot of people who work on the logging site, including those who plan the harvesting rotations. Just as we have complex drawings from which we build our buildings from, they have very complex maps and reports to plan for the growth and harvesting of our forests. They are like the architects, really, of our forests. And so they're planning these logging sites for continuous supply of timber while balancing those considerations for wildlife habitat, natural water quality management, erosion control, biodiversity, and preserving our forests really as carbon sinks. So that's a big undertaking. So we can improve our forest's resiliency to wildfires really by thinning these overly dense areas. Not all trees will really make high value products, but healthy and diverse forest products will be able to absorb more low value material. So as the timber industry matures, manufacturers who really want to stay competitive, well, they'll learn how to use some of those smaller logs and different species that have come from thinning these forests in fire-prone areas. And so public agencies and private companies are investing in this research, testing, and demonstrations to facilitate this process. So In this image here, you can see the timber logs being sorted outside of the manufacturing facility. Inside, though, these timber logs are processed into lumber, veneers, and even strands, which are then used to manufacture engineered wood products. At this particular facility, at least 95% of every log is used for revenue generating purposes. The remaining non-revenue generating material, it goes to a cogeneration plant to generate electricity. So really, everything from the time it comes from the ground to its end use, every bit of that material is being utilized. So how do we convert the timber logs into wood products, right? So this diagram shows kind of the processing chain for engineering wood products. So let's look at the three major categories. We have sawing, peeling, and stranding. So the timber logs can be processed in any one of these three methods. So in the sawing method, the logs are sawn, they're dried, they're planed, and graded, right? And then they're turned into lumber like your traditional 2x material that you would frame your walls with. The next one could be the peeling process, right? The logs are peeled, dried, cut, sorted, and then they're turned into veneers to make things like plywood or mass plywood panels. And then stranding, these logs are chipped into strands of timber, and then these strands are used to make a variety of products like, say, OSB. All right. So on the far right, we see really a wide variety of engineered wood products that can be manufactured from timber logs. And all these wood products store carbon for their entire lifetime. So here are a few images from inside one of the manufacturing or fabrication facilities where the lumber logs are processed. The image on the left shows logs being fed directly into a peeler. The log is fed into this machine. It's spun extremely fast around a blade that slices the log into thin sheets of veneers. The image in the middle shows the wood veneer product stacked up in bundles and going through kind of a drying process. And then the timber logs can also be sawn for lumber to produce your typical 2x studs or joists and other dimensional lumber. Then that dimensional lumber can then be used to manufacture engineered wood products like, say, mass timber panels, like you see in the photo on the right here, stacked up at the shop and waiting to be shipped to their next job. So from small diameter trees, we can really make a variety of engineered wood products. And remember, all these wood products have carbon stored in them for their lifetime. So let's review some of the most common mass timber products. I'm going to be talking quite a bit about mass timber today, so I'll spend some time really explaining the mass timber products. Now, if you've seen some of the other presentations that WoodWorks has done, this slide is going to be very familiar to you. Actually, the next two slides will be. But these are just really giving you kind of an idea about the volume of timber and kind of the applications in which they can be used. So, of course, GLT or glue laminated timber, glue lams, some of our most common, our oldest traditional engineered wood products, right? Used for, say, post and beam frame structures. Then we move on to cross laminated timber or CLT. And this one particularly highlights solid sawn lumber. Now, the image right next to it is a structural composite CLT. So they use structural composite laminations or wood veneers to make mass plywood panels. And so the two of them, very similar. The only differences are, obviously, is one uses dimensional lumber and one uses veneers. Now, let's see, moving on. We have Dow laminated timber or DLT. Now that one uses dimensional lumber, a softwood base material, and uses a hardwood dowel that they will drill a hole through that base material, inject that hardwood dowel into that base material. And what happens at that point is that hardwood dowel actually has a moisture concentration that is less than the base material. And then over time, it will wick that moisture from the base material into that hardwood dowel. It will start to expand and mechanically lock everything into place. So you have a completely green product. Pretty impressive. Nail laminated timber, or NLT, uses just dimensional lumber face nailed to each other to create large panel products. And then lastly, heavy timber lumber decking. It works really, really well in a mass timber project or even just a heavy timber project. There could be opportunities where lumber decking could be chosen over a mass plywood panel or a CLT panel. It still will provide you a beautiful, beautiful aesthetic to your building. So Lumber decking is another option that you can consider as well if for some reason CLT or DLT or NLT is not the right product for your project. So here we see these large prefabricated mass timber panels being lifted and then set into place with a very small construction crew. These panels range from say 8 to say 11 feet in width and up to say 40 to 60 feet in length. It really is a function of what manufacturer you choose. They all have different capacities in terms of fabrication. So with advancements in fastener technology, these panels can be lifted into place and secured quickly with really long self-tapping screws, very, very fast. Mass timber products can be used as structural systems such as floors, roofs, walls, and even frames. So in the image on the left, you see the Soto. That is a 150,000 square foot speculative office building in San Antonio, Texas. The Soto is it's 5 stories of wood and really utilizes dowel laminated timber, or DLT, for the floor and roof panels that complement the glulam post and beam frame. Remember, DLT, dowel laminated timber, that was the one we talked about where they use the hardwood dowel, it expands and locks everything into place. So on the right, you'll see 111 East Grand in Des Moines, Iowa. So this is also a speculative office building that's 4 stories tall and roughly about 64,000 square feet. These mass timber structures will store carbon for their lifetime in this building and longer, honestly, if the wood is reused at the end of the building's life cycle, which we typically see timber being repurposed all the time. So to think that these mass timber products will be in these buildings for 50, 60, 70 years or even longer, and then potentially looking at those being repurposed in the future for something else, you can see that it's locked in that carbon for that entire time. So really impressive. So the advancements in, say, mass timber technology will allow for us to go taller now. So we can have taller wood buildings up to 18 stories in height with the 2021 IBC. So with the evolution of the tall wood building codes, there has been a sizable market that has become available for timber, especially for buildings in the, say, 7 to 18 story range, which have traditionally been constructed with steel or concrete in the past. We now have the option to use mass timber on these buildings moving forward. So let's discuss the idea of, let's say, a circular economy and how that would work. So the interest to apply the principles of a circular economy are really starting to grow here in the US. And so these diagrams are from the government of the Netherlands, who made a commitment. They made the commitment to be 100% circular by the year 2050. In addition, they're also working towards a 50% reduction in the use of the raw materials that they're using as soon as 2030. So that's like right around the corner, right? So on the left, you see kind of this linear economy where we take the raw materials, we go through production, use, and then consumption, and then off to the dump or landfill that material goes. The reuse economy in the middle does have a recycling component associated with it, so that's good in the reuse economy. But then finally, in this circular economy on the right, this really closes the entire loop for us, and that eliminates waste. It optimizes our resources with minimal pollution. It regenerates our natural capital and then reshapes production and consumption from a life cycle and a recycling perspective. So since regenerative resources is one of the principles of a circular economy, today we'll really focus on the raw materials being fed into that loop. So a common misconception is that growth in demand for forest products has a negative impact on forest resources. So in the US, research shows that this is not entirely accurate. So if you look at this graph, at the left of this chart in 1920, right? Let's look at 1920, timber harvest rates nationally were double the rate of forest growth. So, right, we were harvesting way more than we were growing. But by 1952, the net annual growth had exceeded our annual harvest from all US forests. And then by 1997, the annual net growth was almost 4 times what it was in 1920. So that's pretty impressive. And then in 2007, the net growth exceeded harvest by 72%. So you can see that we're doing an excellent job managing our forests, and the amount of growth we're having in our forest far exceeds the amount of timber that we're pulling out of our forests significantly, not just a little bit. So jobs really are a key component to this circular economy that we're presenting here. So utilizing wood products in construction can help support regional jobs and reinvigorate rural communities in the US as well. So in 2018, the wood products industry supported 434,900 jobs in the US with a payroll of about $21 billion. So that's a pretty serious economic impact. Forestry and wood products jobs can help support rural economies, so much that the government of British Columbia has been promoting mass timber buildings as a way to help recover from their current economic recession. So when sourcing from North America, you are directly supporting forestry and wood products jobs in the US and Canada. And so actually, if you wanted to look for some statistics on jobs supported by state in the US, you can go to the link shown here on the map. You can just download that. You can go follow that link and it will give you kind of what jobs are supported by state level. So really a great link for you to take a look at. The National Alliance of Forest Landowners also has a great interactive US map that shows statistics on jobs in timberland acres by state. And then they break down each state into regional districts. So there really is some great regional data you can obtain as well. So I encourage you to download that link and check that out as well. Getting into the green building rating systems, right? So what is a green building rating system? So a green building rating or certification system really broadens the focus beyond the product to consider the project as a whole. We talk a lot of times when you look at a mass timber building, you need to look at it as a holistic approach, right? So this kind of goes well with what we're talking about with the green building rating system. We're not looking at each individual product necessarily. While we can achieve points for having certain products, we look at the project as a whole. Rating systems are really a type of building certification system that rates or rewards relative levels of compliance or performance with specific environmental goals and requirements. So let's see. Although new technologies really, they're consistently being developed to complement the current practices in creating these greener structures, the main goal of green building really is to reduce the overall impact on our built environment and on human health and the natural environment. And we do that by, efficiently using energy, using water and other resources in an efficient manner. Green rating building system measure multiple different categories like planning and design. I've already spoke on energy efficiency, water efficiency and conservation, material conservation and resource efficiency. And that's just to name a few of those. The idea really is to make these buildings more sustainable as well as improving building performance and efficiency overall. The reasons for, say, pursuing a green building certification for a project are really varied. Certification through any rating system provides verification of the green nature of the project, and it can be really kind of a valuable educational and marketing tool for owners as well as design and construction teams through the process of creating a more sustainable building. Green building certification can also be a way to provide an incentive for clients, owners, designers, and users to develop and promote highly sustainable construction practices. And so it's important to note that, a building does not have to be certified to be sustainable and well built. I just want to make sure that I point that out, right? We've all designed several buildings that are extremely sustainable and well built, and they don't have any type of a green building certification attached to them. We all recognize that that doesn't have to happen in order for a building to be a sustainable building and built well. So there really are a wide range of economic and environmental benefits to a sustainable design. Often these are achieved through the use of standards, ratings, and certification systems. And so some common examples would be, say, to reduce embodied carbon, say a reduction in building energy and water use, and increased building value and leasing rates, just to kind of name a few of those, the few of the benefits. So I guess the big question becomes, what green building systems do I have to choose from? So we have the obvious one that most of us are all aware of, LEED, and of course, most likely everybody's very familiar with the Living Building Challenge. We're actually going to just kind of cover two of those today, but there's several other green building rating systems to select from as well. So, and here's just a list of a couple of them that you can look at. Ultimately, the type of certification system pursued for a particular project really depends upon that individual project or that particular project. And so none of these certification systems are really like a one size fits all type system. So there are multiple project variables that can really influence the choice that you make. And those variables can be things like location, the size, the budget, and even the overall project goals are serious considerations when you're selecting what green building rating system that you'd like to use on your project. Generally, every prescriptive based rating system offers a certain percentage of credits that can be achieved using wood products. So in most cases, wood is recognized in areas such as certified wood, life cycle impacts, material efficiency, and waste minimization. And those are just a couple of them to share and then point out. There's a couple of others on this slide as well. Credits are awarded for wood that has been third-party certified as coming from a sustainably managed forest. There are different rating systems that allow for different certification programs as well, with some are more inclusive than others. So be aware of that. And many, I'm sorry, I already said many rating systems give credits for the use of products with lower embodied energy and life cycle carbon impacts as well. So wood products regularly perform well in embodied carbon comparisons of building materials. So really taking advantage of the embodied carbon that wood has is something really strongly to consider. Many rating systems give credit, for use of products with recycled contents too, like finger jointed studs, salvage timbers, even using something like medium density fiberboard and insulation board. Those would qualify as well. Some systems really do place kind of a special emphasis on the use of local materials as an approach to reducing the environmental impacts on the project as well. So rewarding for material sourced, like say from within a certain radius, say commonly about 500 miles, that's a common radius in which that if you're sourcing materials within that particular radius, you can get points from that as well. Many rating systems reward use of lower quantities of building materials as well, as credit is often awarded for avoiding or diverting construction waste through job site protocols. So if you're able to reduce the amount of waste, you can get points for that as well. And most rating systems have strict limits on the use of products that contain VOCs or volatile organic compounds. Many wood products are available that verifiably meet and or exceed those guidelines and requirements. So there are other ancillary benefits and advantages of wood to consider. Obviously, acoustical advantages for sound abatement. that's a really great opportunity to use wood products. I would encourage you to check out the woodworks.org website. We have a fantastic paper on acoustics specifically related to mass timber buildings. So I'd encourage you to check that out as well. New products used in traditional ways. So say, for example, like using wood fiber insulation. We've been using insulation for decades, but now using wood fibers to help us with insulation. And the use of wood framing in wall and roof assemblies can result in less thermal bridging as well. So really, when you stop to think about that, wood is a very poor conductor of heat. So that drastically reduces the amount of thermal bridging that we have in our buildings. So when looking at wood in a LEED rating system, you'll find that the most opportunity to capture points for wood materials is in the materials and resources category, as well as indoor environmental quality category. Those are our two primary areas of points where we can get those related to the use of wood on a particular project. So the use of wood products really can contribute up to 12 points, accounting for more than 10% of LEED version 4's total credits. So also, according to the USGBC, wood is the most highly incentivized strategy for LEED or in LEED. So really important to take a look at that. So in LEED version 4 and 4.1, wood products qualify for credits in 5 different categories. We have building life cycle impact reduction. So wood does well here due to its really low environmental impact. We have the building product disclosure and optimization. So many wood environmental product declarations are available for that as well. So looking into that a little bit further, the building product disclosure and optimization, you can source the raw material from sustainably managed sources. So there's opportunities for points in both of those. Moving on to this slide, taking another look at that portion where we talk about building product disclosure and optimization category. So again, material ingredients such as unfinished wood products as inherently non-emitting sources that can also qualify within the category of low emitting materials as well. So multiple different opportunities in the LEED template, if you will, to gain points by specifying wood on your project. So let's discuss a little bit more where some of your LEED points can come from. So 1 point in sourcing of raw material can be obtained by using the Certified Wood Pilot Credit, an alternative compliance path or ACP. The pilot credit aims to really help eliminate illegally sourced wood from the supply chain. So making sure that you're getting material to your site that is sustainably sourced, you're able to receive a point for that. And an alternative compliance path, what does that mean? So that allows LEED projects to achieve an existing green building credit using an alternative path approach. So this alternative approach now allows you to use wood that comes from SFI forests that have been certified, FSC forests, ATFS, CSA, and PEFC standards. So this opens the door and allows other certification programs to be used in LEED to gain points. You can obtain up to 2 points in the low emitting materials category for the use of wood products. So that covers the little bit that we'll touch on LEED. Now jumping into the Living Building Challenge, or the LBC, is widely considered probably the most stringent green building standard in the world. It really does attempt to emulate a flower by encouraging net zero or even net positive impact on virtually everything the built environment touches. So its requirements are categorized under 7 petals. So place, water, energy, health, materials, equity, and beauty. So through detailed imperatives within each petal, The Living Building Challenge leaves little wiggle room, honestly. Everything is a prerequisite, unlike LEED, where projects teams can choose among credits. Projects can be pedal certified, but can also extend to net zero energy building, zero carbon, living community, or even pedal community. Many of the Living Building Challenge pedal certified projects completed to date have implemented the use of wood and timber framing to meet the materials pedal imperatives as well. So, specifying wood can definitely help you meet that materials pedal imperative. So here's an example of a Living Building Challenge project, the Bullitt Center in Seattle, Washington. The Bullitt Center is a 4-story glulam post and beam structure with a nail laminated timber floor on top of a 2-story concrete podium. So really just a gorgeous, gorgeous building. This 52,000 square foot building has a 250-year life expectancy and is the first Living Building Challenge certified office building. I would encourage you to check this one out. So you can find an excellent case study about this building by visiting the woodworks.org website. Go to woodworks.org website. Let me back up just really quick. You can click on the publications and media tab once you're on our website, and then you can click on the case studies link, and then you'll look for the Bullitt Center. So just a wonderful, wonderful case study. There's a tremendous amount of additional case studies too that I would encourage you to check out. Another beautiful Living Building Challenge building is the R.W. Kern Center in Amherst, Massachusetts. Here you'll find a beautiful 17,000 square foot glulam post and beam frame with a heavy timber tongue and groove decking. And this building is self-sustaining. It generates its own energy, it captures its own water, and processes its own waste. And so here's another opportunity where you can visit our website and download this case study as well. Just another gorgeous building and really an amazing testament to what we can achieve through the Living Building Challenge. One of the frequent questions we hear is, what life cycle assessment tools are there available? So we have, we're not going to jump heavily into this, but point you in the right direction. So we have an expert tip. We have an Ask the Expert that comes out on a regular basis. And we did an expert tip on this that discusses the various software tools available for calculating items like embodied carbon or upfront greenhouse gas emissions. And so you can download these tools. I've put the link here. You can download the tools from the link on this slide. I won't be spending any time digging into the detail of these, but I really just wanted to point you in the right direction. And then you can spend some time reading over the expert tip that we published and learn about the different tools that are available. I will touch on some of the tools really quick. So in the US, two of the most common and robust and like whole building LCA tools are the Athena Impact Estimator for buildings. It's a standalone tool that uses Athena's own highly, say, regionalized database for the US and Canada. That's the first one. And then Tally, which is a Revit software plugin that relies on the international Gabi database. So those are the two big primary ones. One-click LCA is primarily used in Europe, but it is expanding into the US. And the one-click LCA is based on environmental product declaration, or EPDs, that data. And then some experts believe, though, it's not well suited for LCAs due to the inconsistencies between product categories. And then the one-click LCA is part of a suite of products that incorporates life cycle costing and the circular economy analysis that we discussed earlier. So while the whole building LCA tools have the most sophisticated data sets and methodologies for comparing building systems, and as such can yield the best comparisons between wood and non-wood structural systems, they are also the tools most frequently utilized for green building credits and certifications as well. So in general, the whole building LCA considers the production building materials, including raw material extraction, manufacturing and transportation, occupancy, energy demand for an estimated service life, and end of life scenarios with a cradle to grave approach. So, really powerful tool there as well. Finally, let's jump into some discussion on biophilic design. And so, biophilia refers to this idea that humans possess this innate tendency to seek connections with nature and other forms of life. So people now spend about 90% of their time inside buildings, whereas humans originally spent all of their time outside in nature. So in these times of quarantine, we spend even more time inside and realize the importance of connecting with nature and natural systems. So really when we talk about biophilia, it's really simply put as, the human's natural response to being out in nature. Like, what do we feel when we're in that natural environment, in the forest, in the trees? So that's really kind of a summary of biophilia. So here's a great chart. Terrapin Bright Green is an expert in biophilia, and they've written several reports on biophilia as well. This is a portion from Terrapin's table on the 14 different patterns of biophilic design, which summarizes kind of that biophilic pattern and the biological responses that we experience from that biophilic feeling. So we don't get into all of them, but just want to share some of these so that we can maybe start helping you think in a different way. So in this first table here, this includes the patterns that fit into the nature in the space category. Visual connection with nature. So the first pattern is perhaps easiest to imagine. So if you think of a building with, say, a glass wall and views out to nature, that would be your visual connection with nature. A non-visual connection with nature. This second pattern is an interesting one for wood, as it includes items like the smell and the touch. So when you walk into a room and it smells, you can smell the sawn lumber or the fresh cut timber, or you can visually see and touch the grains of the material. And then the last pattern, connection with natural systems, is another interesting one for wood. So wood kind of equals timber, which equals trees, which equals forests, which equals nature. So kind of a convoluted path to get there, but just ways to think about this biophilic response that we're having when we're in a timber building. This next slide includes those same nature in the space patterns of biophilia and considers how wood might contribute to each pattern. So research around biophilic benefits of exposing wood indoors is still relatively early, and more research needs to be done. There really is there's a growing body of research that is starting to be suggested that wood may very well be good for our health and well-being when incorporated into our built environment. We kind of already know this, but there's a significant amount of additional research that's being done to really start to unlock the benefits. The second pattern, let me jump into the second pattern, non-visual connection with nature. Let's imagine, say, walking into the office in the morning and it smells like a forest. You can smell the natural wood material that was used to build this building. The pattern of wood grain really is something humans have been attracted to for ages, right? We can all think of that time where, we were touching some particular wood grain pattern or table or some type of other furnishings, right? Now when we have prospective tenants tour mass timber buildings, they can also smell and touch the feeling of those wood columns and that structure. They smell it, they can touch it, and they're just connected to it. The last pattern would be connection with natural systems, is also, I think, something we've seen tech and other corporate companies use, exposed type wood in their offices to kind of brand their values and show their commitment to the environment and our future. So a couple other areas to look at. This chart covers the natural analogies or patterns in brown and the nature of space patterns in yellow. So material connection with nature is easy for us in that in the wood world to imagine, right? Wood is really the only renewable, bio-based, natural structural material we have to build from. Wood, it's in the trees, right? So complexity and order is another interesting pattern I'd like to talk about. We'll see examples of how wood has been used in complex architectural works, but the wood grain might also contribute to this pattern as well. So when we see a wood grain pattern, it's authentic and it's a story of that piece of material's life. Our purchasing of wooden tables and bowls has shown us that we're attracted to these imperfections in the wood and their natural signs of life, variations in color, luster, texture, and even grain pattern. So we see tree rings and we can start to understand the story of that tree. We see rainy seasons, we see dry seasons. Sometimes we even see scars from forest fires. So really, when you take a step back and you really look at these materials, there's a lot to be told about the story of where they've come from. This is an example. Let's talk about just kind of this biophilic pattern, right? This is an example of the interior of the First Tech Credit Union. The exposed wood material really does provide a visual connection with nature, which again can help lower blood pressure and improve attentiveness and mental engagement, increase your overall happiness as well, and hopefully result in better performance in the built environment. Here you see an interior shot of Albina Yard done by Lever Architecture in Portland. This is one of the very early first mass timber projects. One of the things that surprised the designers of this building was the smell of the office building. It smelled like a forest, they said. It's something that architects don't often even think about. How is the building going to smell when they're designing it? Triggering that non-visual sense can help reduce stress, increase some of your creativity, and your ability to think and learn. Here's an image from the Washington Fruit and Produce Company. As you can see here in this image, wood can be used as an extension of the outside environment and pull that into the interior space as well. You can see the strong visual connection with nature in both of these images. In the image on the left, you will see the Federal Building South with expansive atrium views and robust greenery. And in the image on the right, the Promega Feynman Center highlights beautiful exposed structure and lovely views of trees off in the distance. Visual preferencing of the complexity and order pattern really reinforces that people are happier with an enhanced ability to think and learn. If we really look at how our sensories can really be stimulated in these images here, I mean, just the geometry and the use of the material in these buildings are absolutely stunning. And let's spend our last few moments together looking at a biophilic design of an office building. And so in Australia, they did a report titled Wellness and Wood Equals Productivity. This report surveyed 1,000 typical Australian workers inside their buildings. And they found that those in workplaces had a higher production of visible wood, feel more connected to nature, and rate their working environment far more positively. So wood in the workplace really is associated with higher productivity and reduced sick leave, which translates into more profit for business owners. This is a great comparison that shows a typical cold, dry-walled box office building on the top in comparison to a warm office building on the bottom with exposed timber. You can also see some of the cost considerations to consider on a project like this as well. So when we talk about costing comparisons, right, I talk about looking at the building holistically and not just, material. So some of those cost considerations when you're looking at doing a timber building would be ceiling treatments. Is the mass timber structure serving as the structure and the fireproofing, the fire protection and the finish? Because if that's the case, then it has three functions, right? That's very different to what a steel structure can function as in a building of a similar size. So are we talking about what types of floor topping, HVAC, mechanical systems, foundation size, soil remediation, groundwork improvements, all of those things can impact the cost of the building. And so all of these contribute to the potential cost savings of a mass timber project that we tend to miss when we only look at that per square foot cost, right? When you're looking at, the material, what is the cost of steel versus concrete or wood, and not a holistic building approach. So here are some beautiful images of the gathering spaces for Clay Creative on the left and T3 Minneapolis on the right. And I really like you to look at how these spaces provide opportunities for individuals to recharge or even interact with clients, as well as spaces that connect you to nature through direct outdoor access and an indoor connection through materials and views. Just really beautiful. Research has shown that comfortable and enjoyable working environments really does help retain employees. So consider the cost associated with employee turnover. It's really estimated to cost you somewhere about $25,000 when somebody leaves a company. So you think about, extending extending a working environment to an individual that is beautiful. You're creating a healthy building, an environment where they want to be. They're going to be more productive, can really help reduce the amount of turnover that you have when the employees are happy in their working environments. So millennials, as we're wrapping up here, millennials are estimated to be 50% of the workforce now here by 2020, they were 50% of the workforce, and they care about their office space, and they're creating a demand for mass timber. This generation really does care about the environment, and they want their employers to share those values as well. So wood buildings have a very low carbon footprint, and they provide a means for a circular, renewable economy. Timber interiors provide a hip and healthy atmosphere for employees of these tech companies who are not only advancing sustainability, but also healthy building practices. So exposing mass timber helps to brand the corporate culture through the architecture. So millennials love it for the commitment to innovation and the environment, and kind of a cool and hip place to work as well. And if you want to compete with the big tech companies, don't forget the craft coffee. It really rates high kind of for what the millennials desire in their work environments. So just another beautiful image of Microsoft Silicon Valley. Just wanted to highlight that and show you. And then the last thought I'd like to leave you with today is that wood really is a renewable and responsible choice. And WoodWorks is here to help you make the choice to use wood on your next project. So as you consider wood on your next project, consider giving me a call to discuss how we can help your team create a sustainable and beautiful timber building that will be around for years to come. I'm available to answer some questions right now. If not, feel free to send me an email at jeff.peters@woodworks.org, or feel free to give me a call at 386-871-8808. I'm here to help any way that I can. Thank you so much. It was a pleasure presenting to all of you today, and I look forward to working with you again in the future.